Okay, good afternoon. It's Wednesday, October 28th. This is our class session. And we are completing our week, which is dedicated to exam one. So right now you're working on exam one, and exam one is due by 11:59 p.m. on Thursday, October 29. Submit your exam as one PDF file, including the instructions page signed. With the appropriate file format. Depending on what section you're enrolled in. So the only thing I wanted to do today is answer your questions, and whatever questions you want to ask within reason. I won't answer questions about the exam, but I'll answer any question about any problem in the book, even if it's very close to the exam. I don't know what you've been working on or finished, but I'm going to take questions in order. You're not required to ask any questions, but you can either type them in the chat and we'll take them in order, or you can speak them out, XYZ homework or book, and we will get those posted on the screen for you. You guys go right ahead. I'm just logging into the XYZ homework and book in case you want to refer to any questions that you're sharing. I'll have that going in the background. Here. Okay, got the book open. So we're ready to look at anything there. Just in case you need a reminder, you know where to find our exam on our week 9 page. Right here, exam 1, you just click on this link and you get a copy of the exam. The exam has 5 pages. There are 5 problems. If you need to do additional work, you can label it and attach that, but there should be space there for you to do your work. Just if you attach additional page, just label it really clearly so I know what problem that is and what your answer is. Okay. Oops, that was a mistake. I opened way too many tabs there. Okay, we repaired that. So right now I'm just cleaning up and organizing my stuff and moving papers on my desk. So I'll leave the microphone open in case you'd like to ask a question. But other than that, I'm just going to sit here and work while you're working. Oops, sorry. Part 3A, asking you to show that x is equal to the equation on the right. Yes. I think the answer is yes, and let's just show that so we can all be on the same page. Thank you for the question. Back to the browser. Problem 3A, you're referring to this problem right here. Yes, so you have a diagram with the x and y and h labeled as the lengths of sides of triangles. The alpha and beta are the angles at A and B, labeled DAC and DBC. And so that formula I gave you is a true formula. It is correct. And I want you to show me how I made it, which is using the sides of the triangles and the trigonometric definitions. If that's, is that what you're getting at, Ashton? No problem. So yeah, any question like that about the test is a fair question. You just want to know exactly what I meant. It's fair to ask those kinds of questions. Sometimes people download the notes or look at the video recordings later, but I don't save the chat window for people. I don't want you to think about typing or not typing in the chat, so I don't save the chat. I'll just write down the questions you have on the paper that we're going to copy. I'm looking at Trevor's question, part 3A. You're asking us to show how to find x. Let me admit someone else to the room here. If you want to express it that way, I'll let you express it that way. But I just want you to show me how that formula was made. You could say how to find x. I could say you're looking at the diagram, and maybe the instructions could have been find a formula for x. So if you want to say it like that, that's fine. But I just want to emphasize, let me get someone else in the room here. I just want to emphasize this formula in 3A is correct. And you can show me that it's correct by using the trigonometric ratios of the triangles that you see. And it's not a crazy or complicated thing. It's just showing me how to make that formula. No problem. Hop back to the paper in case people are joining us and they just want to see a record of what we're talking about. Austin's question is very good. And we'll look at the problem. Let me say it like this. You definitely want to follow the instructions. And the instructions say provide this many points. And I provided this method I call the 12 by 4 box method. I've gotten a couple questions on it as we've gone along. I'll show you the page that we're looking at because I was trying to help you find or draw exact points nicely. What I see when I'm doing this is not a fault of anybody, or it's not unusual or uncommon. This is pretty much all the time when you teach someone to draw these things. That I want to make sure I have the handout handy, so I'm going to go get it in my browser. They just draw the basic points and they just draw a nice wiggle that connects the basic points, but it's not the sine graph or the cosine graph. So first you could look at this question. I'll pull up the question in a second. First you could look at this question and just say, I want a perfect graph through the exact points. And then someone's going to say, well, how many exact points? I mean, there's lots and lots and lots of points. Do you want 20 points? Do you want 30 points? And that method that I gave you for showing this, get someone else in the room here, is only meant to say that if you mark the points at every 30 degrees or every pi over 6, you're going to get such a good curve that no one could criticize it. So I am looking at, I'm trying to look at this handout, and I'm trying to look at these instructions. So first, let's go to the problem. Oops, problem number 2. And I'm looking at this. I want to make sure my other camera is involved here. Make sure I got my cameras on the right screens. Sorry. So make an accurate sketch of this function. Got some funny constants in there, showing 2 full periods. Okay, let's start with that in the instructions. There is a lot of problems in your homework that you submitted that just literally didn't have 2 full periods, even though they looked fairly good. So following instructions will mean you show 2 full periods at least. Mark and label the scale on both axes. Again, mark just means a tick mark. Label means tell me what that tick mark is. 1, 2, 3, 4, pi over 4, pi over 8, pi over 12, pi over 6, pi, whatever. You don't have to label every single mark as long as you've got enough marks to be consistent. And I think this is the question that you're asking. They use 13 points in each period as demonstrated in this handout. So in other words, I want at least those points shown in this graph. And when you're doing that, I referred you to this handout. You can use this handout to help you construct it. These are the 13 points that I'm pointing out on this handout. And the goal of these points is to make your curve smooth and regular so that you don't have to work too hard to make sure that you have a great graph. And it's easy to construct those points. I mean, literally, let's see if I can blow this up. You're marking a period from 0 to 2 pi. Now, I know that when you have a different graph, you'll have to change the period. You'll have to change the vertical scale. You'll have to go through several changes, but these dots don't change. If it's a minus sign graph, then it's upside down. The dots are upside down. They're low first and then high. But the dots position relative to each other don't change. You have the middle dots, the high and low dots. Then you have between the middle and the high and the middle and the low, you have these dots that are halfway. So I'll make that slightly smaller. And then between the halfway dot and the high, the halfway dot and the low, you have this other dot that's 3/4 of the box, half and half again. And I make this note down here at the bottom. These final points between the highest and lowest, they are slightly off the real value. The real value would be 0.866 on a basic curve. And half and half and half again is 7/8, 1/8 shy of 1, 0.875. So this slightly different than the truth. But when you look at these curve and you look at this curve and you compare it to anything your calculator or Desmos or anything else does when they draw it, there is no way you could tell the difference between that and a professional drawing. No, connect the dots smoothly. So I respect all of you, and I want to say this. I don't necessarily want to use the word mark down because I'm not penalizing you in any sense. I'm going to turn the question around. If you want the full credit on the problem, 20 points, then you will have to show all those points and do all those instructions, 2 full periods. So I'm not marking you down for anything, but if you don't follow those instructions, you will not receive the full credit. So I wanted to make that very, very plain when I wrote that. And then it's fair for you to ask this question. Well, then I'm just copying the curve. Why is that valuable? Well, you need to gain some experience in this as you go on. But let's put it this way. If you're just copying the curve with the right constants and scale, then it will be the easiest 20 points you ever earned. Now, I'm being a little bit provocative here because I know that nothing is just so easy as repeating those points or copying those points. I know something is not like that, but I just want to be really clear that I want your graphs to be perfect. So the hard work here is working out the scale, the width of the box, the height of the box, the placement of the box in your graph. That's what you're kind of responsible to create. But once you know where this graph is, I want it to look beautiful. So I'm not trying to be too aggressive or anything, but if you want the full credit on that, you have to follow the directions exactly. I just summarized that. And the next time you go on to a class, if you got another class, another math class, another any class, then, it's always, oh, last time the instructor told me to do this. And then next instructor will say, well, that's okay, but that's not important to me. I want you to do this. I mean, everybody has a different style. So every time you have to adjust to each individual class's style. The value that I want to give you to you right here is if you learn how to draw those graphs very, very nicely, then you got a very, very valuable skill. I don't know, maybe life skill when you're 50 years old. I have no idea. But to accomplish what you need to do in this class, yes, very valuable. Good question. Thank you for that question. We go back to paper. And I'll just make one other comment on that method, just so you understand what I mean when I say the 13 points. What you're doing is taking this one period of sine wave, and by making this width 12 boxes wide, you're cutting it into 12ths. You're cutting the 2 pi into 12 equal pieces. But when you count the starting point and the ending point, that is 12 points plus 1, because the ending point is the starting point of the next curve. So that's why I meant 13. I was physically counting these points, breaking the sine wave into 12 intermediate points, and the first point and the last point, and that makes 13. Okay, thank you. Mm-hmm. Problem 41 in book for section 2.5, absolutely. Let me pull that up, and if it's useful, I'll put it on the screen too. Section 2.5. Let me just look it up first. Problem 41, bearing, plane travels for 175 miles on a course of 18, changes course to 49 degrees, and travels another 120 miles. Find the total distance traveled east, north and east. Okay, good. So this is a useful problem. Let me bring it to the screen in case we just want to flash that. 12.5, or sorry, 2.5. $41. I'm gonna expand that. If the silly window will let me do that, and bring it to the screen for everybody to see. Share. Right here. So let me transfer that to the piece of paper, and then I'll go back to my paper. So let's just read it and transfer it. Travels 175 miles on the course of bearing 18. So understand the word bearing. When someone gives you the word bearing and degree measurement and no other information, they always mean the point of reference is from the north. You and I have written in trigonometry that we always measure angles from the positive x-axis, but bearing is a special word that means from the north. So 18 degrees bearing is not very far from the north. And I'll just casually draw something, and I don't know if it's exactly 18 degrees, but I'll pretend that that's 18 degrees. And the distance to travel is 175 miles. I'll add the word miles at the end. Let me get the other piece, and then we'll go back to the paper. It changes its course to 49 degrees, bearing 49 degrees. So then it's looking north, 49 degrees, a little bit past 1/4. So let's say it's going in that direction for another 120 miles, not as far as the first one. And without measuring with a ruler, I think I'm just going to call that 120 miles. And call this angle 49 degrees. Okay, now let's write down the question and then we're ready to go. Find the total distance traveled and the total distance traveled east. Total distance traveled north and east. Find total distance traveled north and east. So I just abbreviate that slightly. Okay, let's go to the paper because that's all I can get out of that information. So here's the key to any problem like this. This is the north. This is the north. And I turned 18 degrees away from the north and moved 175 miles. And I turned 49 degrees away from the north when I got there and moved 120 miles. I don't have to draw those links perfectly. I just drew them fairly, fairly honestly. I have the feeling that one should be slightly longer, but that's okay. Now, the question is, I want to know how far east I've gone from there to there. I mean, I've definitely moved east. This is north, south, east, west. I moved east and I moved east some more. Then I want to know how much I went north. Because wherever I started, I've gone north and northwards again. So if you like, I want to know the sides of this giant triangle. They could have said, how far are you from where you started? Then I'd be asking for this hypotenuse of the giant right triangle. But read the question very carefully. Total distance traveled north and east. They want the length of this side of the triangle and the length of this side of the triangle. Now let's think about how that triangle is going to be made. And I did draw this a little smaller than I would have wished, but you can always print this later. You see this red triangle, but the important part in any problem like this is to see that there are two other triangles. Here's a triangle right here. Green triangle, where I went north and east. And here's a triangle right here. Another green triangle, where I went north and east, north and east. I did it along these black lines. But you observe as soon as you make those triangles that this horizontal length plus this horizontal length is the length that you've gone east. And this vertical length plus this vertical length is the length that you've gone north. So let's just label them really simply. Let's call this one x1 and x2. Let's call this one y1 and y2. Y2 is that short vertical thing right there. And these are two right triangles. These two green things are right triangles. The red thing is a right triangle. So I think the answer to my question is distance traveled north will be the y1 plus the y2. And the distance traveled east will be the x1 plus the x2. So now my mission is find out y1, y2, x1, x2. Now I use the trigonometry. Let's look at, I wrote them in this order, so let's look at them in this order, y1 and y2. y1 is the long side of this triangle with angle 18, y1 is the adjacent side to 18, and 175 is the hypotenuse. Adjacent to hypotenuse is the cosine of the angle between them. So I can write y1 divided by 175 is cosine of 18 degrees. Likewise, I guess I could do x1 while I'm here. x1 is the opposite side to 18, opposite over hypotenuse. x1 to 175 is the sine of 18 degrees. So this is our plan. That means y1 is 175 if you multiply by 175 on both sides, cosine 18 degrees. And x1 is 175 sine 18 degrees. Good. Now, let's think about this logically. I could find out what numbers those are if I want, but this is something else that I'm noticing in your homework. And I'm telling you this now because my goal is that you do it perfectly and without an error. You know, I really don't want to compute these numbers and round off right now. I could compute the numbers, but I'm not interested in y1 and x1 by themselves. I want to know the sum of y1 and y2, and I don't want to round off until the very end, because if I round off along the way, I'm going to lose a foot or a mile or something. I'm going to be slightly inaccurate. So let's just keep these as they are. The calculator will tell me what numbers these are. I may never even see those numbers. I can if I want to. But the number I'm really interested in is that one plus that one plus that one. Okay, let's look at the smaller triangle up here. So 49 degrees is again the angle here, and y2 is the adjacent side. 120 is the hypotenuse. So y2 over 120 is the cosine of 49 degrees. And x2 over 120, the opposite side over the hypotenuse, is the sine of 49 degrees. That gives me y2 and x2. y2 then is 120 times the cosine of 49 degrees. x2 is 120 times the sine of 49 degrees. So now I know the answer. In fact, I could just write the answer. Distance traveled north is y1 plus y2. 175 cos 18, 120 cos 49. But if someone's asking me this question in a physical sense, they don't want a gibberish answer. They want to know how many miles. How many miles did you go north? Just plain English. So we're going to now evaluate that. There's no need to evaluate that until right now. So I just type these in. And let's make sure we're in degree mode since we were working in degrees. We're in degree mode. I can bring this closer to the screen if necessary. 175 cosine 18 plus 120 cosine 49. Make sure I got everything right there. Good. Now calculator evaluates that 245.16 miles and so many digits. So let's talk about what's relevant in the exact figures, although he didn't say use significant digits here, but we got 3 significant digits for the miles. Really, when someone says they traveled 120 miles, I'm going to take them at their word for it that they measured 120 miles, not about 120. Not 124, not 117. So I'm going to take 3 significant digits there and there. And then the angles measured to the nearest degree, 2 significant digits in each case. I think when I gave you instructions on the paper, I told you how accurate to make the answer. But given that they were reporting miles to me to the nearest mile, I guess I would feel comfortable rounding off to the nearest mile here. The problem did not ask for appropriate number of significant digits. So this distance right here is 245 miles approximately. And then you know how I'm going to do the distance east. But just for the sake of completeness, I'm going to do x1 plus x2, 175 sine 18 plus 120 sine of 49. And again, that does not mean anything until I assign a number to it. So I'll just say 17, bring this over here, 175 sine 18 plus 120 sine of 49. It's 69.17 and change. We'll stick to the nearest mile, say 69 miles. So this distance right here is 69 miles east. Now, unlike the problem you're doing on the exam, it did not say how far are you from where you started. So if you'd like to know that in this problem, I'll let you finish that. However, I will say, do not take 2, 4, 5, and 69, go to the Pythagorean theorem with these rounded off numbers. If you're going to pull the Pythagorean theorem out right now, you put in the full number and the full number. Do not round off on your way to the answer. But guess what? The full number is right here on your calculator. So you could use the exact numbers all the calculator gave you, and then your answer would be as accurate as you need it to be. Okay. So I guess the short speech on that problem is, any kinds of problems like this, you use these little triangles to make up a big triangle in some way like that. And he demonstrates that several times in the book. He's doing problems like this. And then I think there was a homework problem I gave you that also was similar. Not the same, but similar. Okay, thank you. That's a very good question. Let me label this one. Section 2.5. Number 41. Okay. I guess we'll scan these and we'll put them on the website after class is over today. I see that, different graph papers get kind of relatively dark lines. So on the camera, that's not always exceptional for reading. But when you scan it, it'll still be readable. I have to use some lighter lined graph paper. Excuse me, I had someone else getting in the room here. Okay. If you have anything else, just bring it. I'm still just cleaning up papers on my desk. Okay. Katoria's question. Very good. And people have come in and out of the room, so I'll just briefly say this again. You could certainly add more, but remember what the basic 13 points that we're looking for look like. Let me go back to this handout. I don't mind. We're looking at this handout where we referred to 12 by 4 box method, and you're asking about the graphing problem, which is problem 2. I don't mind if you add more than these 13 points here. If you think about these 13 points, I took the interval from 0 to 2 pi and cut it into 12 pieces. That's every piece worth pi over 6, as I tried to show you in the picture. Now, that's 30 degrees. We certainly did learn values at 30 degrees, 60 degrees. We also learned the values at 45, which would be halfway between 30 and 60. We also learned the values at 15, which would be halfway between 0 and 30. But then I was getting into weirder fractions and things like that, not as simple to describe. I don't mind if you use more points, but use at least these 13 points. And you'll have something that's, as accurate as you could wish for. So yes, you could use more points if you wanted to. Thank you. That's a good question. Okay. Just send that off. Okay. I also want you to notice, relative to Katori's question and the previous questions about this, is this book has emphasized sine and cosine graphs and not emphasized as much the secant, cosecant, or tangent graphs. I do agree with the book that the most important graphs are the sine and cosine graphs. I'd like to graph all the other ones too. I haven't pressed that because the book didn't make a great point out of it, but you want to be able to graph the other 4 functions, and you can do them with similar nice points as we've done the sine and cosine. But at the moment, unless the book brings you problems that say to graph those other ones, I'm not going to emphasize that right now. So, if you drew perfect sine and cosine graphs, I would be very happy. So use at least those 13 points. And you can add more if you like. I don't want to move to a blank paper, but we'll keep writing down more questions if they come up. I have to see how this exam format's going. Last week, in 2 other classes I teach, I did use the same exam format as I'm using with you. And I guess I'm happy with it so far. So when we come to the next exam, which is in the last week of class, I'm guessing that we're going to do it exactly the same way, unless I find something weird that didn't work. But it seems to be reasonable. If you want to give me any feedback on that anywhere, email or whatever, then you're welcome to do that. Okay. I didn't intend to take a break today because we weren't doing anything in particular. So I'm just sitting here working and reading the exams from the other classes. Remember, after you've handed in this homework last night and after you hand in this exam on Thursday, you don't have a homework that you have to do for the following week because we aren't doing anything this week. So next week we'll start back working and you'll have a new set of problems you can practice, new written homework. I've already posted the next homework, but it's not due next Tuesday. It's due the following Tuesday. And you can find that on our website. Just so everybody's clear on that. So on this week's homework, you have no homework due on November 3. Next homework is due on November 10 after you hand in the exam tonight. Nine point two. 2 minus 6. Problem number 1, section 2.4, no problem. Let me get that up here and then I'll share it with everybody. XYZ homework 2.4, number 1. Let's go backwards here. 2.4. And understanding that all these homework problems are made differently for each person. So the numbers that I'm about to show you here, maybe your numbers were different, but it'll still show you what that problem comes from. Why we're here, that other question, also relevant. First of all, I have to find out what exam problem you're looking at. Number 4. Number 4 talks about area of that road. So you can work out the area of the portion of a circle. You had formulas for the area of a sector of a circle and what section that is in. It's on our formula sheet, but they had a section of the book, 2 sections where he talked about arc length and area of a formula of a sector. So I don't, I'm not, excuse me for interrupting Katoria. I'll do that problem in a second, but remember you had these formulas for arc length and area of a sector of a circle. S R theta. So you can find out any one of these if you're given the other 2. You can also find out the area if you're given the R and the theta. So you can, I don't have that in front of me right now, but I will let you find that. That was a book, that was problems like that from the book. But let's go and do the other one. If anybody knows exactly what section, if they have the book in front of them, I don't mind if you just throw that into the chat. So to this question that Katoria asked, 2.4 XYZ homework, problem number 1. Now, apart from the fact that you might have different numbers, is this, Julia says it's section 3.4 that has the sectors and stuff like that. So people check that out. Is this the problem you were looking at, Katoria, or one like it, even if it doesn't have the same numbers? And I'll write it on my paper and then we'll do it. 2 equal sides of an isosceles triangle are each 26 centimeters. If the base is 40 centimeters, find the height and the measure of the 2 equal angles rounded to the nearest whole number. Okay, so let's draw this. I'm going to draw something like that. I'm going to try to draw it like that. And I'll try to draw it like that. And then I'll try to label it, and then I'll go back to my paper. 26, 26, 40. They want the height, and they want the measure of this angle, which is the measure of that angle. Okay, and they're talking centimeters. And we're talking to the nearest whole number. I see the other question there. I'll look at it in just a second if someone, I don't mind if someone answers Trevor's question just by telling them section. We'll look at it in a second, but first let me finish this one. Some of the questions deal with more than one section in a sense, but I have a feeling for what section. I know the topic, if not the section. Okay, let's go to my paper. Let me just make sure I got all the information I got it. Okay, so isosceles triangle. An isosceles triangle is a triangle that has two sides that are equal. If three sides are equal, it's called equilateral triangle, but here's two sides are equal. Now, let's talk about the symmetry right here. So you think this is 26 and 26. Okay, I got two triangles and 40, but actually, you know, because this is perfectly symmetric, that this height cuts it right down the middle, that this side from here to here then must be 20. And this side from here to here must be 20. And that's going to let us knock this out, because I can use the 20 and the 26, adjacent side hypotenuse. I can use that to find out the h and the angle. So first let's do the h. H squared plus 20 squared must be 26 squared by the Pythagorean theorem. So I got h squared plus 400 is, what is that? 424, 64676. That doesn't sound right. Yes, it does. You shouldn't do math in your head. So let me just check that. 676. Right. So h squared is 276. I don't think that's a perfect square, but let's just take the square root of it and round it appropriately. So h is the square root of 276, which I could simplify a little bit, but rounded, well, it's calculated as 16,613 to the nearest whole number. H is approximately 17 centimeters. Now that's not super accurate, but that's what they wanted, to the nearest whole centimeter. Now, I do not want to use that 17 that I've rounded off and try to find theta. No, I am certain about the 20 and the 26. So now let's find the theta. The cosine of theta is 20 over 26, whichever side I look at. And if I simplify that, that is 10 over 13. So this is a case, we did problems like this, where I know the cosine and I want to know the angle, not I know the angle and I want to know the cosine. So this is pre-programmed into your calculator. This is what inverse cosine is for. So this is how the cosine, how the calculator says, what is the angle whose cosine is 10 over 13? And on your calculator, that looks like this. It's here, excuse me. It's here on your cosine button, way down there. Cosine buttons, 5th row, 3rd button, and there's cosine inverse printed in blue above it on my calculator. So I'll say cosine inverse, 10 over 13. And I think I'm in degrees because that's where I was before. 10 divided by 13, excuse me. So I'll make sure I'm in degrees. Yes, I'm in degrees. That just tells me how I'm going to answer this question. So what angle has a cosine of 10 over 13? And I'm not claiming that I drew this super accurately, but we should 20 to 26. This looks fair. So let's make sure that the theta I get here looks reasonable in my picture. 39.715 degrees. They want it to the nearest whole number. I will say 39 0.715 nearest whole number, approximately 40 degrees. Okay, and I'm just checking. I think they wanted the angle and that to the nearest 40 degrees. So if I said, let me go back to the problem. Let's just pretend we answer it. Centimeters, height. What did we say? 17. And equal angles, the two angles here were both 40 to the nearest degree. And so do we like that? I guess he likes it. Okay, he had a little degree symbol out here. I don't type in a degree symbol. Okay, very good. Let's go back and hunt down the question Trevor asked. Remember, we're recording all this too, so if I'm moving too fast on any one thing, you can always go rescrub the recording. Let me pick up question 3B. Okay, so I'm going to have to slim this down. And I'm going to share. Well, and so now you're looking at question 3A and 3B. You already asked a little bit about 3A. 3B and 3A are related. You can use the triangle from, well, in fact, the instructions say, use the formula from part A to calculate the height of the Zilwaukee Bridge. Answer to the nearest foot. So if you think about that picture and the diagram, picture on the right, map, picture on the right, diagram on the left, you can use that diagram that you just did in part A to answer the question in part B. Now there was problems like this done in the book, and Julia is suggesting there may be 2 3s. That sounds reasonable. Let's go find it. Very much so. In fact, not just the problems. Okay, you got some homework problems in 2 3, but the first thing that caught my eye in section, oh, okay, 2 3 and 2 4. Okay, I see some like it in 2 4 also. I'm just going to verify 2 3. Julia's right. I see a problem like it in 2 3, and I see a problem like it in 2 4. Let me show you. This is from the homeworks in section 2 3. Let me slide this under my camera. Okay, so there's a problem in 2 3 that's a little bit like this. It's not exactly like it, but same setup essentially. But the problem in 2 4 I think is more relevant. Example 7. So example 7 is very much like this problem 3B. This example 7 is in section 2.4. I shouldn't write on the book, but that's okay. It's my book. I can slide up here, but then you don't see the problem anymore. So this is very similar and completely worked out. And worked out a little bit like what we did. So, you can definitely use that as a reference. Okay, very good. Good questions. Thank you, Julia. Okay. Doing this. Tomorrow morning or tomorrow, mid lunchtime-ish, Well, maybe in the afternoon because I'm teaching in the morning. I'll send out a reminder to the class emails about the test being due tomorrow. So just in case I'm not catching anybody here in this session, but you've already got complete instructions and deadlines on the website, but just a small reminder. 2, 6, 1. Problems like the problems you just mentioned is very much like what surveyors do and what you do civil engineer constructing, even, people that come into your house taking down that gigantic, dangerous old rotting tree, you know, they can't take a tape measure to it. So they, can estimate the height just by observing at different places away from the tree. Get a good enough estimate of the height to serve their purpose. And same thing if you have a rangefinder for golf or for hunting, you're using the same principles there. Checking some stuff off here. Okay, very good. No missing. Dum, dum, dum. -2, -2. We'll add that to our paper here. See sections 2.3 and 2.4 in the book. And the other one you asked for, question 4, was about the roadway. And you said section 3.4. I'm just going to check to make sure. Sounds good. Let's specifically that was in section 3.4. Are those two formulas that I had written down on the paper, a couple papers up, were from section 3.4. Okay, very good. Okay. I'm going to let you go in a few minutes, and then you can just go back to work on the test. And you understand the philosophy of the test. Of course, I want you to give me the right answers, but mostly I want to see how you do things and explain things. So definitely show all the steps you're using. I'm not trying to come up with crazy problems. Some of them are very similar to the ones in the book, as you've just noticed. And I just want to see how you explain things. That's mostly what I want. I didn't want the test to be 80% of your grade or anything like that. I think you guys are working hard in the XYZ homework. The written homeworks is for the same purpose, for you to practice writing answers. And, you want to pick up the points there too. But these exams are just a portion of your grade. Each one was 20% of your grade. So just showing me how to explain something to someone. That's when you know something is when you can explain it to someone. That's the hardest thing to do. Is try to explain it to someone else so that they know how to do it too. Is there any other questions you'd like to ask? And you can certainly send me a question by email for the rest of today and tomorrow. And I usually get to your email questions very quickly. As the test deadline approaches, if multiple people are sending me questions, that's going to be hard to get to everybody's questions. So you send me a question by email, no problem. I answer them in the order they come in as quickly as I can. And I'm not always staying awake till 11:59 p.m. So if you have it, ask it. I will copy these pieces of paper and I will post this video, and usually takes me about 10 or 15 minutes to get that stuff posted. And so for that purpose, YouTube is pretty efficient for learning lots of things. Last call on the questions there. Not a problem. You guys just send me any question you want. So you relax, go outside, have a nice day because the sun is out. But then you just, put this together, finish polishing up the test there. I'll see you next week. Have a good day.